Let's take a look now at another class that we're going to make use of, which is the math class. What I've got here are some examples of different things that we can do with the math class. We're going to use some of them more frequently than others. So the online compiler that we're using has the math class built in already. If you are using another compiler, sometimes you have to import it, but the line of code for that is java.language.math. And you'll see math like string are both red, so they're both built-in classes. I don't know if you've noticed that string has had a capital S this entire time. But anyway, we don't actually need this line of code, so I'm going to turn it into a comment. But I am going to import the java.text.number format for this program, just to demonstrate a few things. Okay, so here in the main program, for number format, if we want to use it, so number format percent equals number format dot get percent instance. So when we're using number format, we have to create an object, and then the object has all of the methods that we need around percentage. However, for math, that is not the case. So we'll have a value n here, and I'm just going to make it equal to 1,234. You know what? Actually, we're going to make it a double value, and 0.56789. There we go. That's even better. Okay, so we've got our double value n equal to this. Let's take a look at what a few of these do. Now, you don't have to write out this menu because we'll have most of it in our program here. So system.out.println, what I want to do is to demonstrate. Let's do the ceiling and the floor. So this is for rounding up and down. So the ceiling equals, and we'll go math.ceil, and then we will send it the value n. Okay, and then we'll do the same thing for the floor. Floor. Okay, so let's see what we get here. So I'm going to run the program. So not a gigantic difference between these two values, but we've got 1, 2, 3, 5, which is the rounded up version of this, and 1, 2, 3, 4, which is the rounded down version of this. Now, occasionally, you'll want to have this value not showing as a decimal. And don't forget that afterwards, you can do this. So we're going to typecast that as an integer. And if I run it again, we're going to get the same value without the decimals. Okay? So it's important to note that ceiling gives you, even though it won't have a decimal because it's rounded up, it still is a decimal value. So this will give you a double result, and that's always the case. So if we wanted to do some math with that, we could. So if we wanted to do something like this, system.out.println, and imagine for whatever reason we wanted to add these two values together. So this plus this, that would be fine. So we get two doubles added together, we get a double result. Now, the reason that I've done this is I want to show you what happens when we do this with percent. So system.out.println, let's do %.format. And then here I'm going to pick n divided by 2000 plus %.format n divided by 3000, which doesn't make a lot of sense why you would calculate that. But let's see what actually happens here. So here we get 62%, 41%. Now, it did not add those together. We did not get, 103%. Why is that? So this value here, so this returns a double value. %.format returns a string value. I'm going to turn this into a comment. So whenever you put a plus sign in between two strings, it doesn't add them together, it concatenates them and gives us this as like one string that gets outputted. So that's something that you have to be careful of what type of value is getting returned based on these. Now, what I want to do down here, system.out.println, we'll just say n equals, and then we'll print the value n. Okay. So we get our value as you would expect it. So I'm going to keep going with the math.ceiling here. So system.out.println, and we'll, we'll do the ceiling again. So I guess I could have copied and pasted. So we'll do the math.ceiling n. And then we'll print n again. So what I want you to see here is that we've got n's value here, the ceiling value, and then n again. But this doesn't actually change the value of n. N doesn't change throughout this entire thing. What this does is it takes n, and then this entire thing becomes the value that is the ceiling of n, but it doesn't actually change the value n. So another thing that you want to watch out for is, imagine that we wanted to change n to its rounded up version. We want to round up n. So a lot of people do something like this. So math.ceil n, because we want to take the ceiling of n. So you'll see again that there was no change to the value. N is still this long decimal value. How do we actually change the value of n to be its rounded up self? Well, this gives you the rounded up value of n, but we have to store it somewhere or print it somewhere. So here, I'm going to put n gets the value of the ceiling of n, and then you'll see now it actually changes the value. So watch out for that kind of thing. Now, for a lot of these, they're pretty straightforward. We've got absolute value is just a positive number. It'll remove any negative. Ceiling floor we've looked up. The power here is the first number to the power of the second number. Random numbers we're going to see a little bit later. Square root. Maximum and minimum are kind of nice. You can do something like this. So let's do something with math.max here. So system.out.println, I'm going to do the maximum number of 5 and 7. So if I do that, I get 7, which is the larger of those two. So it returns whichever number is larger. So now imagine that I've got two more numbers, and I need to get the value. Now, if we wanted to do 8 and 10, and then I run this, we get an error here because math.max can only receive 2 values. So how could we actually accomplish this? So we can do a little bit of a longer statement. So I'm going to put a comma here, and then I'm going to put in math.max 8, 10. But what I want to do is I want to find the maximum of all of these values together. So what I can do, I'm going to wrap this in parentheses, math.maximum. And then if I run this, we get 10. So what this does is it uses the order of operations a little bit. So it starts here, generates a number 7 because it's the larger of these. Then on this side generates a 10 because it's the larger of these. And this comma here is separated between the 7 and the 10. And this statement out here is like sending it, trying to find out the maximum of 7 and 10 because it resolves the interior ones first. So you can make methods within methods. Now the only one that's different up here, and they have these parentheses which tells us that this is calling a method inside the math class, and all of them do that except for math.py. Math.py is not a method, it's a value. So if I copy this and write at the end here, I'm system.out.println, and I'm going to do math.py. You see it's the only one that doesn't have parentheses after it. It's just this value of pi that's stored inside the math. And you can see, because this is the grammar of programming, they've put this in all caps because it's a constant value from the math class. Thankfully, it won't let you change the value of pi. So math is really useful. It works again a little bit differently because you don't actually need an object to operate the methods from within it. And I'm sure you're going to find a lot more problems that you can solve using some combination of these methods.